So how can you understand angular velocity, omega, and angular acceleration, alpha? In this short video, I'll try to tell you how you can understand them and what the different directions mean. So first of all, let's look at this circle. It's placed on an x-y coordinate system, Cartesian coordinate system. And then the way we define positive angles is in the following. So let's say I've got something here, it's an angle theta, and I've moved it up above the positive direction of the x-axis. So here's the x-axis, and that's the positive direction, like that. If I move it above there, we'll call that positive. So that's a positive displacement of theta. So anything that goes around the circle in a counterclockwise manner is positive. So counterclockwise is positive, and clockwise is negative. So going down below, that's a negative. Okay? So let's take a look at different situations that we could have here with a disk that's spinning. Imagine we've got a disk and it's got a positive angular velocity. That means it's got to be spinning in this sort of direction like that. Now, if it has a positive angular acceleration, alpha, that's that thing, then what that means is that it's going to get faster and faster as time goes on. So it might start out with that velocity and then pick up speed and go like this, and then pick up speed and go like that. So that's the situation for positive omega and positive alpha. Let's take a look at the next case. Let's say it's got positive omega. So here it's positive omega, but it's got negative alpha. Okay, so here's what's going to happen. It's going to start out going in a positive direction like that, but alpha is going to be acting on it in the opposite direction. And so it's going to slow down a little bit. So what that means is in the next little time step, it might be like that. And the next time step, it might be like that. And then it might stop. And then it might start to go in the opposite direction. So that's how it's going to look if we have positive angular velocity omega and negative acceleration. Let's take a look at this case. Negative omega. So you should immediately think negative omega is going to go like this. So it's going down below the positive x-axis. So it's negative. But its acceleration is positive. Okay? So what that means is that something is causing it to change its direction, moving that way. Okay? So let's look at that. So what's going to happen is it's going to start out like that, and then it's going to be a little less, and it's going to be a little less. It's going to come to a stop, and then it'll start to go back in the other direction. That's what will happen if I have positive angular velocity, negative angular velocity and positive angular acceleration. Let's go to the last case. Negative angular velocity, okay, so that means it's going like this, all right, and negative angular acceleration, which means it's going to pick up speed in that direction, okay? So it's going to go like that. Maybe I need to pick this up a little bit. It's going to go like that, and then it's going to go even faster like this, and then even faster like that. So these are the different cases of angular velocity and angular acceleration acting on a disk. Again, it's defined all by going above the positive axis, the x-axis. That's the positive direction, like that. So I hope this has helped. Let me know by comments if it has, or if there's anything I can improve.